All right, so we're going to walk through a little tradable pollution permit practice problem here. This is from chapter 13 of the OpenStax Principles of Microeconomics textbook. Put the link in the description so you can follow along. And let's take a look. So here is the text of the question. Kind of a lot going on here. So situation, we've got 4 firms producing a product, in this case, wooden chairs. As a byproduct of that output, there's also pollution, garbage in this case. And there's negative externalities associated with that. Underneath this, right, is an external cost of production that's pushing the market equilibrium beyond the socially optimal level, both of the output itself, chairs in this case, as well as the byproduct, the garbage, the pollution. So to reach that socially optimal level, we have government intervention options. And this practice problem here walks through 2 of those, the so-called command and control option, where we figure we estimate the optimal level of production / pollution for each firm, and we have a way of enforcing that level, right? We push output down to that level, and we compare and contrast that in this case with the pollution allowance or tradable pollution permit scheme. Okay, so let's take a look. And admittedly, this question is maybe more complicated than it needs to be to get the point across. So we have 4 firms. We really only needed 2. We have 4 or 5 levels of production with different levels of costs. We didn't really need all of that. But if you follow through with this question, then definitely you get the idea and you can handle any question along these lines. Okay? So in the text, right, there is this table showing our 4 firms, their total levels of pollution production, 20, 40, 60, and 80 from left to right, elm, maple, oak, and cherry. And then underneath that, their associated cost of pollution abatement. And the other complicating factor here is that the pollution reduction costs are measured in 5-unit increments. So when we see our elm firm here has 20 units of garbage, of pollution, it's really 4 chunks of 5 that could potentially be cleaned up. So we'll get used to that quickly. So that's the information. And then down below, we'll see the full table in the next slide. Gives us our increasing cost, so kind of our marginal cost of pollution abatement production. So given all of that, step number 1, calculate the cost of requiring each firm to reduce the weight of its garbage by 1/4. So this would be as if, right, we had that command and control solution. Each one of these firms gets a letter in the mail from the Environmental Protection Agency saying, you have to reduce your pollution production by 25% by such and such a date or face these given penalties. Then we compare that to a situation where the government issues marketable or tradable permits allowing a limited level of pollution, basically allowing 75% of the current pollution levels. See how that generates a secondary market and leads to a lower cost, socially optimal outcome. So let's walk through this. Okay, so here is the full table. And so for each firm, you can really think of these values as tracing out an upward sloping marginal cost curve, right? To produce the first 5 units of pollution abatement, it's 5,500 for elm. The next incremental unit produced has a cost of 6,000, et cetera, et cetera. So these are all upward sloping cost curves at different levels. And we will note that the firms on the outside, on the left, elm, on the right, cherry, are going to be the low cost pollution cleanup firms. And then in the middle, we see on average higher costs for each unit for our firms, maple and oak. So the first part, pretty straightforward, right? The command and control solution. What is the total cost of pollution abatement, bringing it down by 25%? So Half the battle is just figuring out how many units need to be cleaned up. So we could do a little bit of simple math here. So Elm started with 20 units. The required 1/4 reduction is going to be 5 units. Maple started with 40, 25% of 40. It's going to have to clean up 10, or 2 chunks of 5, right? Oak started with 60, 25% of 60 is 15. It's going to need to clean up 3 chunks of 5. And then lastly, Cherry, the big polluter, had 80 units. 25% of that is 20. So it's going to need to clean up 4 units. So then we can just look at the relevant values on those cost curves. Elm only needs to clean up 1. So it's going to be paying $5,500 for that 1. Maple needs to clean up 2, the 25% reduction. So it's going to have $6,300 plus $7,200, and on we go. Oak needs to clean up 3, that 15 unit or 25% reduction. And those first 3 had those costs $7,200, $7,500, $7,800. And then finally, Cherry had the highest level of pollution, the highest number of units needed to be cleaned up, but also the lowest cost. So that'll come into play next. So it needed to clean up 4 chunks of 5 to reduce pollution by 20. And we add those up either by firm, column by column, or as I have here, by unit being cleaned up, row by row, and we get a grand total of $59,500 of cleanup costs. Now, it's important to remember what that represents. That is a resource cost, right? So these are units of land, labor, and capital used to clean up pollution that could have been used somewhere else, right? So there is an incentive from a social welfare standpoint to reduce these costs. If we could achieve the same level, the optimal level of pollution at a lower cost, it's not so much that we care about, oh, it's benefiting the firms that are polluting. It's, well, it's fewer resources being used by society that, again, could be used somewhere else. They have an opportunity cost associated with them. Okay, so that's part number 1. That's kind of the baseline cost of cleanup. Now, part 2, we need to walk through this, right? So in this scenario, the government issues permits allowing each firm to generate 3/4, 75% of their current level of garbage or pollution. Once those permits are issued, right, the firms have a choice. They can kind of stick with what they have, right? Clean up the 25%, keep the permits that allow them to emit the remaining 75% of the pollution, and that would be basically the previous solution that we saw. Or they can buy additional permits to avoid cleaning up units of pollution, or they can sell permits that they have, use the revenue to cover their costs of cleaning up more units, right? So we're going to set up a little supply and demand for these permits. Firms with the high cost of pollution cleanup want to avoid that expense. They're going to have a willingness to pay for additional permits. Firms with the lower cost of production, lower cleanup costs, are going to be more willing to sell their permits. They don't mind doing the cleanup. That's going to generate the supply curve in this secondary market. Okay? So this will be the kind of the initial allotment of permits in this table here. So that first row, again, is the initial level of garbage or pollution being emitted. The next row is the 75% level that they are allowed to maintain given the permits that they will be issued, right? So assuming that we have each permit allows that 5-unit chunk of garbage, the Elm firm is allowed to have 15 units of pollution, so it's going to need 3 permits. That will be its initial allotment. Maple started with 40, 75% of that is 30. That's what the government allows, so it'll give it, that firm, 6 permits. 6 times 5 will allow 30 units of pollution, so on and so forth. So the 75% of 60 for Oak, they are allowed 45 units of pollution, which is going to be 9 permits, 9 times 5. Whew. And then lastly, The high pollution emission firm, Cherry, had 80 to begin with. It's allowed 60, and at 5 units apiece, that'll be an initial allotment of 12 permits. Okay, so again, if everybody just stayed here, right, Oak has 9 permits, it's allowed 45 units, it'll clean up the 25%. It'll be exactly what we calculated in the part 1. But what's the fun in that, right? So these are tradable pollution permits. Let's see how these trades are going to shake out. So again, the big picture here, what we will expect to see, the demand side, the supply side of that secondary market will come from those low cleanup cost firms, right? And their cost of production, the minimum price that they would accept for selling these permits, is just their cost of cleaning up a particular unit. Right? They have to be able to cover that cost. So get that revenue coming in, clean up the pollution, and they can earn a little bit of profit along the way. The demand side is going to be the firms that want to avoid the pollution cleanup, the high cost pollution permit firm, or the high cost abatement firms. Those are the two in the middle in our little table. They're going to be willing to buy with a maximum amount they'd be willing to pay equal to their cleanup costs. So all the numbers that are going to make up the supply and demand are in that cost table that we saw. After all this shakes out, each mutually beneficial exchange is going to occur, right? So every permit that has a minimum price to sell lower than a maximum willingness to pay is going to change hands. And all of those high cost firms are going to avoid the cleanup. All the low cost firms are going to do the cleanup. And we'll end up with the optimal level at the minimum cost. So just to look at those aggregate numbers here, to begin with, we had 200 units of pollution across our 4 firms, the 20 plus 40 plus 60 plus 80. We need to reduce that, right, in aggregate by 25%. So we need to clean up 50 units, or 10 groups of 5 need to be accounted for. It just won't be equally distributed across the board, 25% cut like we saw before. Okay, let's break it down, right? So this is the same table. I've just added a few additional numbers here to think about some of these transactions that are going to occur. Right? So let's start on the left here with the Elm firm. And again, it started with 20. It needs to bring it down to 15. Now, it could avoid cleaning up that one group of 5. Right? It's going to cost $5,500 to clean it up, and that's the most it's going to be willing to pay for a permit to avoid cleaning that up. But since that's a relatively low number, and as we'll see, there's not going to be a trade that's going to be able to happen there, it's going to go ahead and clean up that first unit, right? So it's going to spend that $5,500, and now it's in compliance. But it also has 3 permits in its pocket, right? And it can keep those permits and all as well, or it can sell one of those permits and clean up an additional unit. And that's what's going to happen, right? So that next choice, right? That second group of 5, Elm is going to be willing to sell the permit for any price greater than $6,000. The next one, it will sell that permit and do the cleanup for any price over $6,500, covering its cost. And then lastly, it'll sell its final permit for any price greater than $7,000. So looking at the next 2 columns, we see all these numbers greater than 7,000, likewise greater than 6 and 6,500. Those are going to be the willingness to pay on the demand side. So it is, in fact, going to be able to sell each of those 3 permits to some combination of maple and oak that's going to be trying to avoid their cleanup costs. Right? So in the end, it's going to clean up its first unit. Then it's going to sell its 3 permits and clean up its remaining 3. Right? So it started with 20 units of pollution, and it's going to end up with 0. It's going to clean up all 4 for a total expenditure of 55 plus 6,000 plus 6,500 plus 7,000, or 25,000. So right off the bat, we've already got 4 of the 10 units cleaned up. So far, so good. So hopefully that makes sense, right? So this is the beginning of the supply curve of these permits. Let's switch to the other low-cost firm on the right, Cherry. And again, at the beginning, it has to bring its pollution down from 80 to 60, right? So it's going to need to clean up those first 4 groups of 5 to bring it into compliance. Its other option would be to buy permits, but its costs are so low, nobody's going to be willing to sell for that price, right? So Cherry's going to go ahead and clean up its 4 required units. And it hasn't done anything with its allotted permits yet. Right? So it still has 12 permits, and now it has the same choice, right, that Elm did. It's in compliance, but now they'd be willing to sell that 1 extra permit, or that next unit permit, for any price greater than 7,000. And as we saw, we have these willingness to pay values above that. So someone over here is going to purchase that. There's going to be a negotiation, a transaction that takes place, and it's going to need to clean up that 1 extra unit. So in total, Cherry will clean up 5 units, right? The 4 initially to bring it into compliance, and then the 1 extra because it sold a permit. So the 3 plus 4 plus 5 plus 6 plus 7,000 brings us up to 25,000 total expenditure. Okay, so there's only one more unit that has to be taken care of. So we had 4 cleaned up by Elm, 5 cleaned up by Cherry. The remaining unit being cleaned up is going to be this guy here, right? The relatively low cost first unit cleaned up by our firm Maple, right? It will clean up that 1, but it's going to want to avoid cleaning up its second. Right? And it's going to buy a permit for any price less than 7,200. And we have a variety on sale, right, coming from Elm and Cherry. So it's only going to clean up that 1 extra unit. It's going to clean up this guy, but it's going to avoid cleaning up that one. So that was the 10th unit cleaned up. We are now in 25% reduction compliance. All the permits, right, are in the hands of the higher cost units, and the firms doing the cleanup are the lower cost options. So let's add all this up and just verify, right, that this did work out, that our total costs are lower than the command and control. And thank goodness it checks out, right? So again, our pollution cleanup came 4 units cleaned up by Elm, spent 25,000, 1 by Maple, 6,300. Oak, right, ended up not doing any cleanup because they bought the remaining permits. The higher cost firm avoided the cleanup. They were on the demand side. And then Cherry cleaned up 4 plus the 1 extra for selling its permit for 25,000. Add all that up, and we've saved a little over $3,000 compared to the command and control cost. So our total expenditure here is 56,300 after all those transactions take place. And the question didn't actually ask for this, but to get a better visualization, we can kind of sketch out unit by unit what those demand and supply curves are going to look like. So we saw Oak had the highest cost, right, recorded for 7,800. So that's going to be the maximum willingness to pay for that first permit on the demand side. And then its next highest value was 7,500. So that second unit also demanded by Oak. The third unit with a cost of 7,200 from Oak as well. And then we saw Maple had that one of 7,200 as well. So that's going to be the demand curve for the 4 permits that were traded in this example. And then the supply curve, we saw those 3 coming from Elm, 6,000, 6,500, 7,000 after it cleaned up its 1. And then Cherry, after it cleaned up its 4, had 1 permit to sell for 7,000. So somewhere in the middle here, let's call it 7,100, there's going to be an equilibrium price that's going to be set. Right? But each of these gaps between willingness to pay and cost of production is telling us there's a mutually beneficial exchange that can happen there. And again, the end result, socially optimal level of production, brought it down by the required 25% at a lower cost by letting the firms sort out which side of the market they're going to be on. So hopefully that was helpful. And I'll see you guys next time.